Hey guys, welcome to the third video for SYSC 2100, 2003, and today we're going to be talking a little bit about, I don't know why I labeled it branching, I'm just talking a little bit about how we use compare statements and branching statements to help write programs, and this is how we'll start getting into stuff like subroutines and how to write functions. As you would see in higher level languages, you call them functions, right? Yay. So we're going to be learning how to get behind the lower end of that. So let's start off here. I'm going to go a little bit back to basics. I'm just going to go over a few things. So first let's look at this piece of code, and I want to label the different parts of it, just so I know that you guys know exactly what everything is called in here. So first, these org statements here. These are known as directives. So these tell you exactly where I want to put the code here, or like where I want to put this data, or where I want to put this code in this case. So that's what a directive does, just points you to exactly where you want to put your code. Next right here is my RMB. This is known as a data directive. This tells you where and how you want to store certain data, and it's used in different kind of variable declaration. So that's what a data directive is here. I've directed my variable hehe to reserve a memory byte, like one byte of memory. And there's different types of data directives you can also get. You also got EQUs, which declare constants and give them a value. You also have stuff like FCC, which fills constant character, and you can set a string of characters to be set at a certain memory location, and there's many more that I encourage you to look at. So next thing I want to look at here is these two parts of the statement. So right here is known as your opcode, and here is your operand. And as you know, the opcode basically just tells what the instruction wants to do, and the operand just says where, if there's any memory locations involved, which memory locations to use. Next is this end statement. This end statement is how we end a program. So this is known as another directive, basically. And this directive tells you when to finish your program. And finally, the last one I want to look at here, and it's kind of the one we're kind of focusing on today, is the label. And the label just basically breaks up your code. If you have many different labels, so you can have main as the main part of your program, or you might also have calculate max or something along the lines of that. You have all your code here, all your code here. I want a way to break up all this code so it looks cleaner, and I'm able to go from different parts of my code in a way, or using what we'll learn next, using branching. And to do this, we need labels. So this is why I wanted to go over the different parts of code, because we're going to be introducing a new one today called the label, which we'll use in our to branch between different parts of our code. Okay, so now I've mentioned it a couple times. We are now going to talk about branches. So, what are branches? So basically, I just will use those to branch go from one part of a code to another. This can be done. There's only one way to do it unconditionally, but usually they're done with a condition. And if you think about it in terms of, say, Java, if you say you had an if statement and you want to say if I is greater than 0 or something, then do this. This is how you would do it in assembly language. So let's go over a few different branch statements. So first is the unconditional jump, and it is bra. So this bra statement, it is done whenever it can be done whenever. There's no need for a condition to be satisfied to use it, and usually it's used to escape a loop. Say you're doing a loop in your statement, you'll use bra to escape from that loop. So next is your BGT, which is branch greater than. So your branch greater than is just a conditional jump. If a number is greater than another number, then it will jump to wherever you want it to. Next one I want to look at here is B high, and it will branch if a number is higher than another number. But hold on, why do we have two of them? Okay, so something you got to remember about these processors is that they read everything in binary, right? Well, binary numbers have two types of numbers. First is the signed number, and there's the unsigned number. So your signed number can tell you if you have a negative number or not, and your unsigned number basically can't. So if you have an unsigned number, you would want to use branch high. But if you have a signed number, then you want to use branch greater than. And it's really up to you to know when to use both those branches. So now let's look at these two. Here's the BLT command. Sounds delicious. The BLT command just says if you're branching if something is lower than a number, or one thing is lower than another. And then there's also less than a number, not lower than, less than. And then now there's B low, which is branches if lower than. And that's if if a number is lower than another. So again, there's two of them that are very similar, and this is because there's a signed version and an unsigned version. So you have to understand what signed and unsigned numbers are, and then you'll know exactly when to use these different types of branching. So those are just a few examples of branches, and there's actually so many more. I just listed 5 of them here, but there's a lot more than that, and they're actually very useful conditional statements, and I encourage you to look at all of them. Alright, so next up we're going to look at the comparative statements. So these things are used to tell the branch statement when exactly to jump between different things. So say if you wanted to compare registers B and A, you would use this command, CBA. And it's pretty self-explanatory. What it does is it subtracts the number inside A from the number inside B, and it'll tell you, doing that operation will tell you if A is greater or equal to B, or if B is greater to equal than A. Basically, it just tells you which one is greater than the other. Unfortunately, you don't have this for, say, if you wanted to compare X and Y. It's only available for A and B. So we'll do an example later where we would use CBA in one situation, and where we'd have to use something like this, compare X. And compare X only compares to a certain memory location. It doesn't compare to another register. So let's look at CMPA, and this just compares whatever in register A to another memory location. So whenever you write the CMPA command, then you always have to write a memory location after it, just to make sure. And this memory location can also be a constant. So it can be something, it just has to reference some memory location, so you're able to take the data in there and compare it to register A. And it's the exact same thing for B and for the rest of this one compares register Y, this one compares register D, so like it'll take A and B and then subtract it from the memory location you reference plus the memory location plus 1, because remember D has 16 bits, so it's 2 bytes, so it's taking 2 registers, and now we'll look at 2 memory locations. And finally you have compare your stack pointer. That's what CPS does. So